Welcome to Maths for You YouTube channel. A past question on trigonometry. Let ABC be a triangle and let D be the point on BC such that BD is to DC equal M is to N, where M and N are greater than 0. It is given that angle BAD equal alpha and angle DAC is beta. Using the sine rule for the triangles BAD and DAC, show that MB over NC equals sine alpha over sine beta, where B equal AC and C equal AB. Let's do the first part and then we'll come to the second part later. So a triangle, I just sketch a triangle ABC, and again D is the point somewhere along the BC, and the ratio BD to DC is M is to N. So they are supposed to use sine rule for the BAD and DAC. So BAD, this is sine rule BAD. I just wrote this BD over DC M over N, cross multiplication, and this, anyway, just leave it. So sine rule BAD triangle. So BD over the sine of opposite angle. BD over sine of opposite angle is alpha, is given, and AB over sine opposite angle ADB. Then sine rule for ADC, the other triangle. DC opposite angle beta, so sine beta equal AC over sine. The BDA, the angle we took it for the first sine rule, just ADB, BDA, ADB, and I want to use the same angle, so that is it's a straight line. Therefore, sine 180 minus ADB. Instead of they put in the angle, that's 180 minus the angle already been used. Sine 180 minus sine. This is sine identity. Sine 180 minus theta equals sine theta. Sine 180 minus theta equal sine theta. That we have used here. So 180 minus ADB is ADB. So just simply the same, right? Okay. So the first equation is BD over sine alpha equal AB over sine ADB, and the second equation DC over sine beta equal AC over the same sine ADB. If you would divide one another, equation 1 divided by equation 2, the left hand side simply divides the BD over sine alpha, and then the flip over the other one, sine beta over DC equal. The sine ADB will be cancelled out. So AC, where is it? AB over sine ADB times sine ADB over AC. Therefore, AB over AC. AB over AC, right? So B, if we could sort of tidy up or rearranging it, BD over DC, left hand side, BD over DC, sine beta over sine alpha equal AB, as we given to take AB as opposite C angle, C, and AAC is opposite to B angle, is B. So AC is given here. AC is B, AB is C. So that's C over B. Then cross multiplication, sine alpha sine beta equal, so sine alpha sine beta equal that B over C, BD over DC. So simply B over D, BC over B over C, BD over DC. BD, we know that BD is the portion of M times BC. The M is given M to N the ratio. So BD is M times BC. The total is BC. So M times BC So BD instead of BD, M time BC, instead of DC, N time BC, N time BC, and B over C. The BC cancel. What we have, sine alpha over sine alpha over sine beta equal MB over NC. Is that what we want? Yes, NB over NC. That's what we have to prove. That is done. Then the next part, it says hence. So I just use the first part. Hence is a strong hint, strong instruction to use the first part for the second part. So show that MB minus NC over MB plus NC equal tan alpha minus beta divided by 2 cot alpha plus beta divided by 2. Right, let's go for it. So this is what we do. MB minus NC over MB plus NC equal tan alpha minus beta over 2 cot alpha plus beta over 2. That is what we have to prove. So this is what we have to prove, right? What we know from the first part, the NB, I just changed the sign. MB over NC equals sine alpha over sine beta. That's the first part. So as I said, the hence is a very strong word in it. So that will help the second part. So we are using the first part. This we proved it. MB over NC equals sine alpha over sine beta. All I have done, just subtract minus both sides to get NB minus NC. So that will, so simply subtract minus both sides. So MB minus NC over NC equals sine alpha minus sine beta over sine beta. That is the equation A. Then the same MB over NC sine alpha sine beta. This time add 1 to both sides. That gives us MB over NC divided by NC sine alpha plus sine beta over sine beta as equation B. Now, if we could divide A by equation A by equation B, so simply the NC cancelled out, MB minus NC over MB plus NC. That is equal. The sine beta, the denominator cancelled out, so sine alpha minus sine beta divided by sine alpha plus sine beta. So that's what we want to prove. We need to prove that tan and cot. Before that, I took right-hand side. Right-hand side is sine alpha minus sine beta over sine alpha plus sine beta. We know for the sure the sine A minus sine B, that is equal to cos A plus B over 2 sine A minus B over 2. That is the top part. And sine A plus sine B, that is equal to sine A plus B divided by 2 cos A minus B divided by 2. So that is exactly what we are using there and here. So it's right hand side, so it's just sine alpha plus B. So A is alpha, B is beta, so 2 cos alpha plus beta over 2 sine alpha minus beta over 2 divided by sine A plus sine B, so 2 sine alpha plus beta over 2 cos alpha minus beta over 2. So now we have 2 that is cancelled out. That's 2 cancelled out. What we have, cos alpha plus over cos alpha plus beta divided by 2. Here we have sine alpha plus beta divided by 2. That is cot alpha plus beta over 2. Then sine alpha minus beta over 2 and cos this, and that is tan. So therefore, tan alpha minus beta over 2 times cot alpha plus beta over 2. That is what we have been asked to show. That's done. Now the third part, C part, show that tan inverse 1/3 plus tan inverse 4/3 equal pi by 2. Pi by 2. So, okay, let's see that. Right, to tan inverse 1/3 plus tan inverse 4/3 equal pi by 2, we have to prove. So I just took A equal tan 1/3, tan inverse 1/3, B equal tan inverse 4/3. That means tan A equal 1/3, tan B equal 4/3. We need to, we just see whether we can prove it. So 2a plus 2 is 2 times tan inverse. So a is tan inverse 1/3. So we have 2 1/3. So 2a, and 1b is pi by 2. We have to prove this. We have to prove. So 2a plus b pi by 2. This is what we have to prove. Let's deal with this. So this pi by 2 is tan. If you take tan both sides, say 2a plus b, pi by 2, we have to do it. So what we have to prove, if I take tan both sides, tan 2a plus b equals tan pi by 2. If I could prove that pi by pi by 2, tan pi by 2 is infinity. If I could prove that, then job done. So just from pi by 2, I just wanted to prove that tan pi by 2. If I can prove that infinity, therefore the angle is pi by 2. 2a plus b is pi by 2. Right, okay, let's do that. Just deal with this left hand side. So tan 2a plus b. So this is again trigonometry identity. Tan a plus b equal tan a plus tan b divided by 1 minus a tan b. That's what that's the formula I used. So a is 2a, b is b. So tan 2a plus tan b divided by 1 minus tan 2a tan b. Tan 2a again, this one. So you can write this one is what tan a plus a. So that's tan a, okay? It's tan a plus tan a over 1 minus tan a times tan a. This is tan 2 tan a, 1 minus tan squared a. That is tan a. We have identified 1/3. So tan 2 times 1/3 divided by 1 minus tan squared is 1/3 squared. So that from that, the top one is 2/3, the bottom one is 1/3 squared is 1/9. So 9 minus 1 is 8/9. And if you could flip it, then that will be 3/4, 2/3. 2 and 4, 8 is 4 common, and 3 and 9, 3. Therefore, it's 3/4. Tan b, 3/4, already we know that. Tan b, we took it as 3/4. Right, let's substitute the value. What we need to prove, this 1 minus tan 2a times tan b is 0. If you could prove that, the whole thing is infinity. It's the whole idea. So it's right hand side is infinity. So 1 minus tan 2a tan b equal, so just the denominator, 1 minus tan 2a tan b is 1 minus tan 2a is 3/4 times 4/3. That is 1 minus 1 is 0. So the denominator is 0. Therefore, the right hand side is denominator 0, infinity. Therefore, 2a plus b is pi by 2. Thank you. Please subscribe the channel and share the contents with other students and friends. Thank you.